Hi everyone. Hi everyone. So let's study. Let's solve some questions in file organization. Is the audio video volume, is everything clear? Okay. So all the concepts that we have seen, we will do the practice of every concept. Basically, I have taken 4 or 5 questions I have taken. Each question contains almost 5 or 6 questions. So total, if you notice, total 25 questions I have taken in these practice set. Okay. So total 4 questions. In each of them, there are like 3 questions, 7 questions, 3 questions, 4 questions, something like that. So almost 20 questions or 25 questions I have taken. In these questions, we will cover everything. Okay. In the file organization, every concept that we have seen the block header. Okay, there is a block header, there is a record header. For every record there is a header, for block there is a header. Okay, and all the concepts that we have seen, block size, record size, spanned organization, unspanned organization, okay, block factor. So every concept that we have seen in the file organization, each and every concept we will apply in these questions. Okay, see, whenever you study some concept, you understood the concept, that is very good. But when you will get the confidence, when you solve the questions, when you solve some good questions, and all these questions are standard. In this session, every question that I've taken, each and every question is standard question from standard books, either from Ullman book or from Navathe book. Okay, so all the questions are standard and very nice and very quality questions. And when you solve these questions, definitely you will get more confidence. So the concepts we have already seen, the concept of file organization, the concepts we have already seen. Now we will do some practice. Let's start. Okay, so let's start with the first question, that is question from the Ullman. This is a question from the Ullman book, Database Systems, the complete book by Ullman. Okay, and second edition. This is the question. So you can read the question and tell me what will be the answer. So the question is this: suppose a record has the following fields in this order. Okay, so in the record you have these fields in this order. The order is also given, the order of the fields that is given. Okay, so a character string of length 15, an integer of length 2, okay, 2 bytes, SQL date and SQL time. Okay, so and this information is already given, you can check it out. This information is given that SQL date has 10 bytes and SQL time has 8 bytes. Actually, this information actually is not given in this question. If you check this question in this book, if you check it out, this information is not given in the question, but this information is given in the book. Okay, so in the question this information is not given, but in the book this information is already given. Okay, so anyway, so I have written this here, that SQL date has 10 bytes and SQL time requires 8 bytes. So this information is given. Now you tell me, field can start at any byte. How many bytes you need for a record? So the record size, the question is asking. The question is asking the record size. Okay, very simple question. The question is asking about the record size. So what will be the record size? What will be the record size in the first scenario? So the question is saying the part A. What the part A is saying, that fields can start at any byte. They can start at any position, they can start. So this situation is very easy. In this situation, your answer becomes extremely easy. Okay, what you can do, you can just put all these records in the given order and your answer will be like this. Okay, so that will be 15 bytes plus 2 bytes and plus SQL date, SQL time. These are 10 bytes, 8 bytes, 10 bytes, 8 bytes. So your answer will be like you can notice your answer will be 35 bytes. Okay, so this is your first question, the record size the question is asking. that will be this. Record size is this. What the question is asking next? The question is asking fields must start at a byte which is multiple of 4. Okay, every field must start at a byte at an address. Okay, I can say at an address which is multiple of 4. Okay, byte address multiple of 4. So what should happen? So multiple of 4. Remember, every field should start, okay, at a byte address which is multiple of 4. At a byte address multiple of 4. Have you seen this type of question? Have you already seen this type of question in the C language? So this type of questions in the C language you have already seen, right? Correct? Okay. So in the C programming we have already seen this. Sachin has already taught this structure alignment. So this concept in the C language, there is a concept structure alignment. Okay. So all the variations are already done, right? Yes or no? In our C language course. In the C language course, this structure alignment we have already seen. Okay. In the C programming, this concept we have structure alignment, and this we have already seen. All variations we have already studied. Okay. So all variations we have already studied in the C language course. Okay. In C course. Okay. So this you can basically, hope you remember these concepts, right? Okay, structural alignment, some variations can be created, some very nice questions can be created from this structure alignment. Let me tell you one thing. This structural alignment, this is a topic from which in the GATE exam there is no question, but in all other good exams there is a question from the structure alignment. You will find questions in the TIFR exam, in the GRE exam, in all the exams. Okay, your NET exam, NET GRF exam, in all the exams there is a question from the structure alignment, but in the GATE exam so far there is no question. But this is a very nice topic. Okay, and all the variations we have already covered. Each and every variation from the standard resources we have already covered. So I think by chance if this question comes in the GATE exam, you can easily solve this. Okay, this was a really simple topic, this structure alignment. Now anyway, the similar scenario is this. So the every field should start at a byte with its multiple of 4. And remember, in this order, you cannot change the order of the field. So the answer will be what? So actually this first field, okay, how much space it will take? It will take 16, right? Okay, because you can just basically this 16 bytes, because you can just I can say round up to multiple of 4, right? Correct? Yes or no? You can basically round, I can say round 15 to multiple of 4. Is this clear? To multiple of 4. So that basically 1 byte padding you will do. Okay, so round 15 to multiple of 4, that will be equal to 16. Okay, so 1 byte we will do padding. This is called 1 byte padding we will do. Okay, so like this. So anyway, 16 bytes plus what this will become? This also you can multiple of 4. Okay, this also you can round multiple of 4. So this will become 4. This will become 12. And this will remain as it is 8. So your answer, what your answer will be? That will be 40 bytes. Okay, very simple question. Is this clear to everyone? Let me know. Okay, is this clear? Let me know. Very simple. Nikhil, is this clear? Any doubt? So the question is saying that, see, the question is saying every field should start at a byte address multiple of 4. How 36? How are you getting 36? This will take 16 bytes, right? Correct? What are you saying? This will take every field should start. Every field should start. Every field should start. Every field I am saying. Field, attribute. Field means attribute. Field means attribute. There are attributes and this is an attribute. Is this clear? So the question is talking about field should start. Field means attribute. You already know this. How many attributes are there? How many fields are there in this question? How many fields are there per record? Per record, how many fields are there in this question? There are 1, 2, 3, 4. 4 fields are there. Is this clear to everyone? Is this crystal clear to everyone? Okay, just very simple, round up to multiple of 4. Okay, because everyone should start at multiple of 4. This should start at multiple of 4. This should start at multiple of 4. Everyone should start at multiple of 4. Okay, so this 4 is fixed. In the structure alignment questions, can you notice there this type of questions we ask, like every field should start at the multiple of its own size? Yes or no? In the structure alignment, this variation we have done, that every field should start at the multiple of its own size. Yes or no? This type of question, this type of variation are done. Like the integer should start at the multiple of 4. Float should start at the multiple of 8. Double should start at the multiple of 16. So every field should start at the multiple of its own size. That is a different variety of question that we have already done. Sachin has already done in the C programming course. And in this variety, there is a fix. Everyone should start at multiple of 4. These varieties, did you understand the difference? Tell me, did you understand the difference between these two varieties? Here, every field should start at multiple of 4. Another variety, another variation, every field should start at multiple of its own size. Yes or no? Yes or no? Every field, integer should start at multiple of 4, float should start at multiple of 8, double should start at multiple of 16. So here every field is starting at multiple of its own size. And in this question, what we have done, every field should start at multiple of 4, so that 4 is fixed. So this question is very easy. In our question is very easy. In our question, what we are doing, we are just, I can say, in our question, we are just rounding up to 4. Every field you round up to 4. So our question is actually very easy. Okay, so very simple. Now tell me the answer for the next question. Every field should start at multiple of 8. The third question, the part C. Okay, everything should start at multiple of 8. What will be the answer for this question? So quite easily you can do. You can round up to multiple of 8. Okay, so the answer will be this 15. This 15 will become 16. This 15 will be actually, it will be stored in 16 bytes. This will be stored in 8 bytes. Correct? This will be stored in 8 bytes. This will be stored in 16 bytes. This will be stored in 16 bytes, and this will be stored in 8 bytes. Okay, so this will be stored in 8 bytes. So your answer for this will be 48. Okay, that is going to be 48 bytes. So quite easy questions. Correct? Right? Okay. So like this you can do. So these questions we have done. This is your question from the Ullman book. A very nice question. Simple question, but a nice question. Okay, so the answers you can see like 48, 40, 35. These answers we got. Okay, let's see. Let's see the next question. What the next question is asking? The same question. Repeat the same exercise. See, this we have done. This we have done. This we have done. We got 35 byte here. We got 40 byte here. We got 48 byte here. Okay, these questions we have done. Now the next question is this. Repeat the same exercise, exact same exercise, review, repeat. But now the list of fields is given. The fields are changed. The list of fields are a real of 8 bytes, a character string of length 17, a single byte, and a SQL date. Okay, so now this is the given. So 8, 17, 1, 10. 8, 17, 1, 10. This is your size of the fields, right? So what will be the part A? Remember your fields are like this. 8 byte. Okay, 8 byte, 17 byte, 1 byte, 10 byte. 8 byte, 17 byte, 1 byte, 10 byte. So these are the size of fields. These are the 4 fields that are given to you. Okay, so for the part A, anyone can start anywhere. The part A is saying the fields can start at any byte. So if the fields can start at any byte, then that is very simple. That is your these many bytes. Okay, so you can check it out. So I think this will be 36 bytes. Next. Next will be what? B. What will be the part B? Every field should start at multiple of 4. every field should start with multiple of 4. Okay, so field start with multiple of 4. Field starts, or I can say every field starts at byte address multiple of 4. Multiple of 4. Okay, so this becomes very easy now. So you just round everything to multiple of 4. So this 8 will become 8. This will become 20. This will become 4. And this will become 12. So this will become your answer. Okay, so the question is actually now very easy. I hope you are finding that this is a very easy question now. Once you understand this, once you understand anything, it becomes very easy. Okay, so this is your answer. Now, finally, the answer here, what that will be. So you can check it out. I think it will be 44 bytes. Okay, next, what is the answer for the next? The same question, but multiple of 8. But multiple of 8 every. Okay, so very simple. Now you round up to multiple of 8. So this will become 8. This will become 24. This will become 8. And this will become 16. So the answer will be what? This is going to be the answer. So your answer is 32. Okay, 32 plus 24. So that is 56. Your 56 bytes you got. So very simple. This is your answer. Now let's move on. Let's see this question. Actually, I want to give you this question as a homework, but maybe we can do this. Or this is a question from the basically magnetic disk. The complete question is from the magnetic disk. So let's solve it. Okay, this is not a complicated question. Let's solve this. So let me solve this question. Can you take your copy pen, because it is a very long question. A lot of things are asked. In this question, we are asking a lot of things. So can you take your copy pen? This is going to be a long ride. This question is going to be a long ride. So this is a question from the Navathe. Okay. Question number exercise 16.34 from the Navathe 7th edition. So very nice question. You can notice total how many parts are there. So 5 and 7 parts are there. A lot of questions, a lot of things we are asking in this question. So let's solve the first part. Let's start with the A. Tell me what is the A. What A will be? So consider a disk. A disk is given to you. Remember, a hard drive is given to you. A hard disk is given to you. The characteristics are given to you. And the question is saying that block size is 512 bytes. Inter-block gap. Okay, block size is given to you. Inter-block gap is also given to you. Between two blocks, what is the gap? That is also given to you. Number of blocks per track, that is also given to you. Okay, so basically the information is already given to you. Next, number of tracks per surface and a disk pack with 15 double-sided disk. Double-sided track platters. Now let's see. So in the part A, 2 questions I am asking. What is the total capacity of track? Tell me, what is the track capacity? What is the track size? That is very simple. Number of sectors per track, correct? So what is the number of sectors per track? How many sectors we have per track? Or you can say in terms of number of blocks. In terms of number of blocks. Okay, so how many blocks you have? So you can see number of tracks per surface. So track capacity, that will be what? So there are total 20 blocks. This you will multiply it with what? There are 20 blocks, right? In terms of block, you can find there are 20 blocks multiplied by total track size. That will be 512 bytes. See what we have, 512 bytes, and plus there is a 128 bytes gap. There is 128 bytes gap. So this you will multiply with 20, right? Yes or no? This will give you the total track size. Remember, this is the total track size because there are blocks. This is for blocks. This is the block size that is given to you. And this is the inter-block gap. This is the inter-block gap. Inter-block gap means between two blocks, what is the gap? Between two blocks, what is the gap? What is the gap? Inter-block gaps means between two blocks. What is the gap? So your answer will be what? That will be 20 multiplied by 512 plus 128. This is your answer. Okay. So because if you have 3 sectors, then there will be 3 gaps. See, if you have 3 blocks, if you have 3 blocks, there will be 3 gaps. So if you have 20 blocks, there will be 20 gaps. Is anyone has any doubt? Let me know. So there are 20 blocks. So there will be these many blocks. Is there any doubt? So intergap. Total. See, there are 2 things in this. Look at this. Part A. Read the part A. Total capacity of track and what is the useful capacity. So there are 2 things in this part A. In the part A, there are 2 things. Read this. Read the question part A. Read it. There are 2 things. What is the total capacity of the track and what is the useful capacity of the track? Is this understood? Let me know. Please tell me, is this crystal clear? So the question has 2 things in the part A. What is the total capacity? No, they will mention, Navathe. Don't worry, see, in the GATE exam, you can check it out. There are multiple questions like this. In the GATE exam, there are 3 questions. In those 3 questions, they are asking track size and useful track size. Are you getting my point? You can check it out, 1991, 1993. So there are 3 questions. In the GATE exam, there are 3 questions. In all those 3 questions, they are asking what is the total track size and what is the useful track size. You can check it out. Those GATE questions, you can check it out. In the GATEOverflow PDF, in the Go PDF, go to the disk. This disk chapter, the disk questions you will find in the operating system. In the GATEOverflow PDF, go to the operating system section. There you will find disk. This disk section you will find and solve the first 3 questions. In the first 3 questions you will find, those are GATE questions. In those you will find they are asking for the total track size and also they are asking for the useful track size. So the total track size will have everything. And what is the useful track size? That is different. Is this clear? Let me know. Navathe, is this doubt clear? So you can notice. So if you have 20 track, if you have 20 blocks, see, if you have 20 blocks, okay, 20 blocks imply 20 block gaps. Inter-block gaps. Okay, so if you have 20 blocks, then there are these many gaps also. Array, just read, see this. There are 3, how many? Tell me, Sriram, how many? These are the 4 blocks. How many gaps are there? 4 blocks are there. How many gaps? This is a gap. 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 Is this clear? Let me know. Okay, so this question is clear. That total track size will be what? This will be total track size is this 20 multiplied by this. And what is the useful track size? What is the useful track size? What that is? Useful track size. What that will be? That will be 20 multiplied by 512. This will be the useful. These many bytes and here these many bytes. So this is your first question. Take your copy pen. If you watch it like a movie, you will not understand many things. If you watch this question like a movie, this is a big question. Many things we are asking in this question. So if you watch this question like a movie, like a Netflix, if you watch this question, you will not understand many things. Take your copy pen. Okay, let's see the second. So this we have done. First part we have done. What is the second part? How many cylinders are there? Tell me, how many cylinders are there? So which statement is correct? Number of cylinders. Can I say that is equal to number of tracks? Can I call it number of, can I say it is equal to number of tracks? Can I say this? Can I say this? What is the number of tracks in this question? What is the number of tracks? In this question, what is the number of tracks? In this particular question, what is the number of tracks? So in this particular question, number of tracks per surface is 400. Okay, so 400 per surface. On one surface, these many. multiplied by how many surface are there? 15 double sided. Okay, so these many surfaces. So your number of tracks will be what? So this will be equal to 12,000 tracks. But number of cylinders is only 400. Right? So this is 400. So this statement is not correct. So this statement is not correct, right? Correct? Yes or no? Number of cylinder is 400. And because what is number of cylinder? I told you that number of cylinder is equal to number of tracks per surface. Number of cylinders is equal to number of tracks in one surface. On one surface, how many tracks you have? That is your number of cylinder. So per surface, you have 400 tracks. This will be your number of cylinders. Okay. So don't make this mistake that number of cylinders is equal to number of tracks. This is not correct. Number of cylinder equal to number of tracks per surface. On one surface, how many tracks you have? Okay, so this is done. Now, what is the next question? The next question is, what is the total capacity and total useful capacity of cylinder? For cylinder also the same thing we are asking. Part C. What is the total capacity? Cylinder capacity. I am asking for cylinder capacity. So in a cylinder, how many surface you have? In one cylinder, how many surface you have? So there are 30 surface. There are 30 surfaces. Okay, multiplied by one track size. Correct? Yes or no? Because I am asking for the cylinder. So this is your cylinder. So this is your cylinder. So you can notice number of surfaces. So there are 30 surfaces. There are 30 surfaces. And what is the track size? And what is the track size? Total track size. So that will be 30 multiplied by total track size. That is 20 multiplied by 512 plus 128. This will be your answer. Is this clear? So this is the answer for this question. Total cylinder capacity. This is your total track size. This is the total track size. Okay, what is the second? What is the second? Okay, because for a particular cylinder, I am asking for a particular cylinder capacity. The next is useful cylinder capacity. Useful cylinder capacity. What is that? So useful cylinder capacity. That will be 30 multiplied by useful track size. Okay. So that will be useful track size. So don't include this 128. So your answer, actually your answer will be 30 multiplied by 20 multiplied by 512. So these many bytes. This will be your answer. Everything is coming in bytes. Okay, let's see the next. What is the part D? So this is done. What is the total capacity and useful capacity of the disk pack? How to do that? So total disk capacity. What is that? Total disk capacity. That is very simple. Okay, I can call it number of cylinders. Number of cylinders multiplied by total cylinder capacity. Total cylinder capacity. Right? Can I call it like this? Okay. So total number of cylinders is 400. And this we have calculated. Okay. This we have calculated. You can put it here. Similarly, useful disk capacity. What is that? Useful disk capacity. That will be 400 multiplied by useful cylinder capacity. This data we have already calculated. Okay, this data we have already calculated. This data we have already calculated. This data we have already calculated. You can put it. That's it. Okay, we only want to understand the logic. Now, Let's see the next E part. So see, in this question, everything is there. In this question, in this particular question, everything is there in this single question. Okay, now let's see this. Suppose the disk drive rotates the disk pack at the speed of 2400 rotations per minute, revolutions per minute. So you tell me the average rotational delay. So first you tell me the average rotational delay. So the question, the E part. Let's see the question number E part. So 2400 rotations per minute. This is the rotational speed. Okay, so it means what? So tell me the latency. The question, if the question is asking, what is the average rotational delay? What is the average rotational delay? See, this is also called average latency. They can also, okay, they can also ask you, this is also called average latency. Is this clear? This is also called average latency of the disk. For the disk, what is the average latency? Or you can call it average rotational delay. Okay, or you can call it average latency. And this is what? This is half of, I can say, one rotation, right? This is half of one rotation time. One rotation time. So the answer here, the answer is half of one rotation time. Okay, so that is, I can say, that will be half of one rotation time. Because on average you will do half rotation. Correct? On average, you are going to do half rotation. So first of all, here you can notice that in 1 minute, how many rotations you can do? 2400 rotations in 60 seconds. So one rotation, how much time? So one rotation, how much time? That is 60 divided by 2400 seconds. In the millisecond, you can find it out. Okay, the answer will be 1/2. In one rotation, how much time you are getting? How much time? I think 25 millisecond, right? 25 millisecond. In the millisecond, you can find it out. You can multiply it with 10 to the power minus 3 up and down. Okay, so it will become, see, this you have. Okay, so if you multiply with 10 to the power 3 and you multiply with 10 to the power minus 3, so that 10 to the power minus 3 second, that will become millisecond. That will become millisecond, and it will become 60,000 divided by 2400. So that will be 25 millisecond. So finally, it is 20. This is your average delay. Your average latency will be this. What else the question is asking? What extra the question is asking? The question is asking that what are the transfer rate in bytes per millisecond? Transfer rate the question is asking. Okay, in the part E, we are asking transfer rate. Is this transfer time or is this transfer rate? Transfer rate, I told you this transfer rate. How much data you can say per second? How much data you can send per second? Okay, so this is what the question is asking. How much data you can send per second? Now the question is asking that give me in bytes per millisecond. Find bytes per millisecond. Per millisecond, how much bytes you can transfer? Okay, so how to answer this? So you can notice in one rotation, how much data you can transfer? In one rotation, how much data you can transfer? You tell me. In one rotation, you can transfer the entire track. So what the question is asking that, yeah, okay. So the question is asking what are the transfer rate in bytes per millisecond? So in one rotation, you can transfer entire track. Entire track we can transfer, correct? So we can transfer entire track size. In one rotation, you can transfer entire track. Okay, and what is the track size? The track size is basically 20 multiplied by 512 plus 128. So this much actually you can transfer. Okay, so So here actually the complete we have to transfer. Transfer rate will be total track size. Yeah, yes. So we have to actually take the total, because that much you can do. See, we are only interested in one rotation, how much you can do. In one rotation, how much you can transfer. Okay. So in one rotation, we can do that. In one rotation, the entire track size we can transfer in one rotation. This much amount of data we can transfer. Okay, in one rotation. So your answer will be what? And one rotation time is already given to you. So that is 25 millisecond. In the 25 millisecond, this much amount of data you can transfer. Okay, so per millisecond, 1 millisecond, how much data you can transfer? 1 millisecond, how much data you can transfer? That will be this divided by this. So this actually you can call it 512 plus 128. What is this total? This you can add, this is 640. Okay. So in 1 millisecond, you can transfer these many bytes. Can you calculate what is this? Can you calculate what is this value? How many bytes can you transfer in 1 millisecond? What value will come if you calculate this? Take your this calculator and tell me. This 25 divided by this. So this will be 24, these many bytes. Is this clear? Is this correct? Let me know the calculation. Do the calculation with the help of calculator. Okay. So this will be 20 into 640. Okay. So you can divide it by, so 12800. Okay. So finally it will be, I can say 512 bytes. See one thing. Okay. Transfer rate. This transfer rate simply tells you how much data can you transfer within a single rotation. Sorry, within 1 second, how much data can you transfer? Okay. See, this comes in per second. Per second, how much data can you transfer? Now let me tell you, if you see, some of you are thinking that should we take useful capacity or should we take the complete track capacity, right? Yes or no? This is your doubt. I agree. Okay, agree. This is your doubt that how, okay, what should I take? What should I take? So actually you can think like this. The reason why we are taking the entire size is this. The transfer rate has nothing to do with track size, correct? Actually, this is we are using to calculate. Please understand. We are using track size to calculate, but actually transfer rate has nothing to do with the track size. But we are using that to calculate because we know that, okay, in one rotation, you can transfer this much amount of data. See, the transfer rate talks about per second or per millisecond, per unit of time, how much data you can transfer. Are you getting my point? Okay. So remember, per unit of time, how much data we can transfer. Okay. So here, of course, we are transferring the useful data, but per unit of time, how much data we can transfer. So actually, this entire track size we are taking to calculate the transfer, to calculate this transfer rate. But actually, transfer rate has nothing to do with the track size, because transfer rate means how many bytes we can transfer per millisecond. There is no track size in this. Are you getting my point? What I'm saying? See, what is the transfer rate? What is the definition of transfer rate? In the definition of transfer rate, there is no track size. Do we mention track size in the definition of transfer rate? Tell me. In the definition of transfer rate, do we mention the track size? There is no track size. Do you have to take the track size? No. You can take any data. Like for example, if I know that, okay, if I know that, let's assume, if I know that one sector, one block I can transfer in 1 millisecond, then what my answer will be? If I know that one block I can transfer in 1 millisecond, then what will become the transfer rate? One block I can transfer in 1 millisecond. So I can say my transfer rate will be, what is the size of the block per millisecond? Are you getting my point? Is this clear? Size of the block per millisecond. So in the transfer rate, why we are taking the entire track size? Is this clear? Let me know. Because transfer rate has nothing to do with the track size. you can take a small part of the track and you can calculate the transfer rate. Is this clear? You can take a small part of the track. This is your track. This is a very big track. In that big track, you can take a small part of the track and you can calculate how much time this data will take to transfer. Are you getting my point? See, this track size we are taking just to make our calculation very easy. But actually transfer rate is this. This is your track. If I know that this data I can transfer, let's assume this is your data. Let's assume these are the K bytes. If I know that this data I can transfer, let's assume this data I can transfer in maybe I can say maybe S millisecond. So this data I can transfer in S millisecond, then what will be the transfer rate? Then what will become the transfer rate? The transfer rate will become is K divided by S. Okay. So S millisecond. So per millisecond, this much bytes per millisecond. This much bytes I can transfer per millisecond. Tell me, is this clear? Did you understand this concept? The transfer rate has nothing to do with the track, but we are taking the track size just so that our calculation becomes easy. Okay, let me know, is this crystal clear? Okay, so the transfer rate basically only says how much data can you transfer per second. Let me know. Clear? So in the transfer rate, we are taking this track size. The reason we are taking this track size, I told you. Okay, because you can take any small part and then you can calculate the transfer rate. For this part also, like from this small part also, you can calculate the transfer rate. Okay, now let's move on. So the next point is the block transfer time, BTT. BTT means block transfer time. What is that? Tell me the block transfer time. In the same part, what is BTT? So that is actually now very easy. You know that in 1 millisecond, how much transfer you can do? In 1 millisecond, this we have already found. These many bytes you can transfer, right? And I'm asking block transfer time. I'm only asking transfer time. I'm not asking the entire time. The transfer time asking, block transfer time. So in 1 millisecond, the entire block, this is the block size. If you notice, this is already the block size. This is already the block size. So what is the block transfer time? BTT, that will be 1 millisecond. One block I can transfer in 1 millisecond. Is this clear? Let me know. See, very simple. Because I am asking transfer time. How much time? Okay, to transfer one block. So here you can notice in 1 millisecond, I can transfer 512 bytes. That is the block size. So block transfer time is very simple. That is 1 millisecond. So this question, okay, part E we have done. Any other doubt? Let me know. So this done, this done, this done, this done. All of them, are they clear? So far, is everything clear? Okay, now let's see the next. That is, suppose the average seek time is given to you. Okay, time to go to correct track mechanically. So this average seek time is already given to you 30 milliseconds. This is the average seek time. How much time does it take on average? Okay, how much time does it take in a millisecond to locate and transfer single block given its block address? So now you have block address, you have to locate and you have to transfer. Another very nice question, part F. So in the part F, what we have to do? So block address is given to you, right? Okay, so in this given a block address, so basically I can say the complete time we have to, okay, block address is given. Now block address is given. Okay, so if this is given, then what we have to do? Now total time, you locate and you transfer it, right? Okay, so basically you have to locate it and you can transfer it. So that is basically your total time. What is that? Total time will be what? That will be access time plus transfer time, right? Okay, so that will be access time plus transfer time. So the total time that we will take, because block address is given to you, The only information that you have is block address. So this block address will be given to you. So now you have to, okay, what is this access time? I told you access time is nothing but seek time plus rotational average, of course, average seek time plus average latency. And this you already know. Block transfer time is already 1 millisecond. And this average seek time is already given to you 30 millisecond. And this average rotational latency is already 12.5 millisecond. This is your answer. Okay, so total answer is what? Can anyone tell me? 43.5 millisecond. This will become your final answer. Okay, because see, the question is very, very, very nice question. Every information is given in the question. Can you see in the question, every information is given, very crystal clear, every information is given. There is no ambiguity in this question. Do you agree or not? Tell me, do you agree or not that there is no ambiguity in this question? Every information is really given. And this is the difference of standard questions and very poor test series questions. Have you seen in the last few days, in the GATEOverflow group, in the GATEOverflow Telegram group, in the goclass Telegram group, in the public Telegram group, can you see poor questions? Nowadays, very much poor questions are increasing. Almost for every questions, we have to say that, why are you solving these questions? Now read those questions and read this question. Which question will give you more good feeling, like I can say satisfactory feeling? This question, isn't it giving you satisfactory feeling when you solve this question? This question is very well framed. Every information is given. Okay, every information. There is no ambiguity. There is nothing, like, so everything is given in the question. This is a standard question. This type of question they ask in the GATE exam. But if you solve these Hulu test series, all these test series, okay, these test series, as I told you, these are created by GATE aspirants. These are not created by I can say professors. These are not created by professors. Even these are not created by faculties. These are created by aspirants. The aspirant, the student who is preparing alongside you, you are also preparing, he is also preparing, he is creating the test series, you are solving those questions. Will you like to solve those questions or will you like to solve the standard questions? That is the reason. These standard questions, whenever you solve one standard question, it will give you very, I can say, best feeling it will give you. You will feel like maza aa gaya. You know, it will definitely, it will give you very nice feeling whenever you solve a standard question. And in the Go classes, practice set, test series, weekly quizzes, homework, okay, we only solve the standard questions. A lot of standard questions we solve so that we get the feeling of joy. Okay, so that we don't waste time. Anyway, so you can see, actually, this question is very beautiful question, very nicely framed. Every information is already given in the question. Now what the question is asking, the next part, calculate the average time. The question is asking, calculate the average time it would take to transfer 20 random blocks. Read the question carefully. Okay, so it would take to transfer 20 random blocks and compare it with the time it would take to transfer 20 consecutive blocks using double buffering. Actually, what is this double buffering? This is also given in the question. Now you don't have to actually worry about what is double buffering, right? See, in the double buffering also this information is given, that you don't have to take seek time and rotational time again and again. Are you getting my point? Now you, okay, see, in the question everything is given. In this double buffering, what this double buffering is, basically the double buffering is saying that if you have consecutive blocks, then you only have to take one seek time and one rotational delay. Is this clear? So this double buffering is a technique. This is actually a technique, but to solve this question, you don't need to do this technique. You don't need to use this technique because already the information is given in the question. So in this double buffering, basically, this is used when you have consecutive blocks. If your blocks are consecutive, then this double buffering technique is there. And using this technique, you don't need seek time for every block. Only one time you have the seek time and one time rotational delay. So you can save the seek time, you can save rotational delay. So this information is also given in the question. Is this clear? So this information is also given, that single seek and single rotational delay. Is this clear? Let me know. The information is already given in the question. You don't need to know what is double buffering. Okay, but there is a double buffering. This is a technique. In this technique, whenever you have consecutive blocks, then you only need one seek time and one rotational delay. So anyway, this information given. Okay, let's solve this question now. So if you have very random, let's solve the question. If you have 20 random blocks, in this situation, what we need to do? The total time will be, that is very simple. That will be 20 multiplied by everything, like 40.5 millisecond that we have calculated, right? This 43.5, this millisecond that we have calculated. Agree or not? Because 20 random blocks you have. Okay, so 20 random blocks. This is one block. Okay, this is per block time. Okay, so you have random blocks. So you need everything. Okay, so you will have 20 multiplied by, every block will need a seek, every block will need an average rotational latency, and every block will have transfer time, right? BTT. So seek plus, okay, for every block, these three things you have to do. Now in the same question, if you have 20 consecutive blocks, in the same question, if you have 20 consecutive blocks, okay, using double buffering, with a double buffering, the question is already saying that double buffering, what double buffering means, the question is already saying that you don't need seek or you don't need rotational delay again and again, because you can save. See, the question is saying you can save seek time and you can save rotational delay. Both of them you can save. So in this situation, what your answer will be? Your answer will be, see, one time you need seek, one time seek plus one time rotational delay. One time seek, of course, these are ones. These are ones. But after that, 20 multiplied by 1 millisecond. For every block, transfer rate only you have to calculate. Right? This is the transfer time. This is your block transfer time. BTT. So 20 multiplied by 1 millisecond. So this is your question. That's it. All the parts of this question we have done. Okay. So how much practice? Tell me. All your concepts are revised or not? Tell me. In this question, all the magnetic disk concept and all the concepts, I don't think anything is remaining. Okay, last part. The last part we have done, right? The average time, we have found random blocks and with those. Nikhil, any doubt? See, there is a double buffering. There is a concept double buffering. Okay. You don't have to basically study this. There is a concept of double buffering. There is a concept. In this concept, what happens? There are two buffer. Okay. So let me tell you, actually, you don't need to know this. It is not required for the GATE exam, but what happens? In the main memory, there are two buffers, buffer A, buffer B. Now what happens? When CPU is using buffer A, then you will fill buffer B. When CPU using buffer B, you will fill buffer A. Are you getting my point? This is called double buffering. Is this point clear? This is called double buffering. So the concept of double buffering, what happens? You have two buffer in the main memory. So when you initially you transfer the one block, just transfer one block, one seek time, one rotational delay, transfer one block. Okay, so transfer block to one buffer. There is a buffer A. In the buffer you transfer, CPU will use it. There is another buffer. So when CPU is accessing this buffer, you will fill this buffer. When CPU using this buffer, you will fill this buffer. Is this point clear? This is called double buffering. So there is a concept of double buffering. This is called double buffering. In this double buffering, what happens? That you basically one time seek time, one time rotational delay. More than this is not required to us. Are you getting my point? You can save on seek time. You can save on this rotational delay. So this is the concept of double buffering. Please tell me, is this clear? You don't need this for the GATE exam. That is the reason I did not teach it. But whatever I told you right now, this is double buffering. That's it. Okay. So there are two buffer in the main memory. From the disk to main memory, you will transfer the data. One block will go to buffer A. When the buffer A is processing, CPU is taking this buffer A. CPU is processing buffer A, then you will put then you will put the next block in the buffer B. CPU is processing this, you will put next block in the buffer A. So buffer A, buffer B, buffer A, buffer B. So like this is called double buffering. But in this question, this information is given. In the GATE exam also, this information will be given. Are you getting my point? These type of things are given in the questions. Like in the GATE exam, if this question comes, they will mention it that like in this question it is given. You can check it out. Okay, double buffering to save seek time, to save rotational delay. Okay, any other doubt? Let me know. Tell me, any other doubt? So you understood this double buffering, right? Double buffering simply means that there are two buffers. Double buffering means there are two buffers in main memory. Two buffers in main memory. So there is a buffer A, there is a buffer A, there is a buffer B. So there are two buffers. So when you are filling this, CPU will use it, or you will, okay, so like this. So there are two buffers. Anyway, this is not required for the GATE exam. There is no need for this. Okay, but this is the concept, double buffering. There are two buffers. So when you use this, when you process this, then you can fill this. Then when you process this, you can fill this. Okay, so very like in a very fast manner, you can do these things. Okay, this is the concept of double buffering. Anyway, so in this concept, what happens that in this concept, basically single seek, single rotational delay. But this question is very nice because in this question, information is given. Okay, you don't need to understand double buffering to solve this question. Yes or no? This double buffering, because in the question they are saying what double buffering means. Double buffering means you can save the seek time, you can save the rotational delay. Of course, one time seek, one time rotational delay must be there. Okay, now let's see the next question, that is from the Navathe book. Another very nice question. Let's solve it. Okay, so take your copy pen. This is another very nice question from the Navathe 7th edition. Let's solve this. So block size is given to you, that is 512 bytes. So the question is saying that there is a student table. There is a student table. In this student table, there are these many records, 20,000 records of fixed length. All the records have fixed length. And the question is saying that every record has these fields. Fields are given to you. Name is a field, SSN attribute, address, phone number, birth date, sex, major department code, minor department code, class code, degree program. Okay, so total how many fields are there? So total 9 fields are there. Okay, total 9 attributes are there. You can check it out. And what this question is saying, every record has these 9 fields. Okay, every record has fixed length. So what is the length of record? What is the record size? Before solving, what is the record size? What is the record size? See, every record has fixed length. Every record has fixed length. Okay, it has fixed length, 9 fields. Every record has 9 fields. Okay, so let's see this. So the total size will be very simple. That is, okay, 30 bytes for name plus 9 bytes for SSN, for 40 bytes for address, 9 bytes for phone number, 8 bytes for birthday date, 1 byte for sex, 4 bytes for major department number. Okay, next 4 byte for minor department, class code and degree program. These are 4 plus 3. Okay, but some more information is there. An additional byte is used for deletion marker. Okay, in every record, one additional bit is there. One additional bit is there, plus one additional bit. Where can you put it? You can put it in the record header. This additional byte is there. Sorry, this additional byte is there. You can put it in the record header, right? Yes or no? Okay, so this additional byte you can put in the record header. So every record has this additional byte. That is, an additional byte is used for deletion marker. the file is stored with the parameter. Actually, this basically the parameter that we need to know, that is block size. The block size is already given to you, that is 512 bytes from the previous question. Actually, these questions are linked. You know, problem one that we have done, these questions are basically linked. The problem one that we have already done, okay, that problem we have already done. In that you have these, this is the block size. Okay, so what is the record size? This is your answer. So tell me, anyone, what are the totals? Can you calculate this? Can anyone calculate this? Is this correct? 113 bytes. Is this correct? Okay. Now, let's see the calculate the blocking factor. Blocking factor we have to calculate. First of all, you calculate the blocking factor. What is the blocking factor? Which organization we have to use? Okay, the question was also given unspanned organization. See, this question keeps getting better and better. Every information is given, no by default. If this information is not given, then what you would take? If this information is not given, then you would take unspanned. I told you unspanned is by default. So this information, so actually this is already given in the question. So blocking factor, you have unspanned organization. So blocking factor will be what? That will be number of records that you can store per block. In one block, how many records we can store? So total number of records are 20,000. Sorry. In one block, how many you can store? So the record size is already given. The block size is 512 bytes, and the record size is 113 bytes. So tell me, how many records can you put in one block? In one block, how many records you can put? That will be 512 divided by 113 floor, because it is unsigned. So your answer is going to be what? This floor value you have to calculate. So your answer will be what? I think it will be 4. You can check it out. Okay, so 4 records you can put. The blocking factor will be 4 records. So total 4 records you can put. Okay, the next question is asking how many file blocks you need for this file. Okay, so how many file blocks you need? Number of file blocks, now number of file blocks, or I can say number of blocks for file. How many blocks for file? In the file you have, remember, there are 20,000 records. There are 20,000 records. In the file you have 20,000 records. This question is already given. These many records you have, 20,000 records you have. Okay, in the file. Now we are asking how many blocks you need. So that is very simple, right? Because 4 records per block. 4 records per block you can write. So in one block, 4 records you can put. In one block, 4 records you can put. So these many records will need how much? 5,000 blocks. You need 5,000 blocks. Is this clear? Let me know. Tell me, is this point clear? So you need 5,000 blocks to store this. So, okay. So this question we have done. Problem A, problem B. Is this clear? See, back-to-back questions I am solving. From the file organization, we are solving all the variety of question. I can promise you that from the file organization, whatever we have seen, question cannot come outside of it, because we are solving the standard questions. We are already solving the standard questions, so question will not come out of this. Navathe question, Ullman question, Ragurama Krishnan. So all the standard books, whatever type of question, whatever variation of question can be created, we are already solving those. Okay. Anyone has any doubt in this previous question? Let me know. Yeah, okay. So this is a very nice point. Ekta, can we do this? Ekta is saying, can we do this? Can we do this? Okay, can we do this? Number of blocks is equal to, what do we do? Can we do this? Number of blocks is equal to total file size you find Okay, total file size you find divided by block size. Can you do this? You tell me, can you do this? Tell me, tell me, tell me. Do you remember Priya was doing this? Priya was doing this in the last class. But that was for unspanned. At that point, one thing I told you in the last class, in the file organization lecture, this technique Priya was using. The complete file size you find, divide by block size. At that time, I told you one thing. What was that? Do you remember, Priya? What point I told you at that time? That this technique is only for unspanned. For spanned. For spanned, you can do that. But for unspanned, you can't do that. Is this clear, Ekta? Is this clear? See, can you see what problem will happen? Because this is unspanned organization. You are finding total file size divided by block size. This will not give you wrong. If you do this, okay, if you do this, or maybe seal, does not matter. See, whatever you do, this is wrong. So can you do this? The answer is no. Can you do this? Can you do this? The answer is no. Why the answer is no? And this is most common mistake. Let me tell you. Let me tell you, this is most common mistake. Okay, almost 3 years ago, 4 years ago, I have written some answers on indexing on the GATEOverflow website. In most of my answers, there will be at least 1 or 2 comments where the students will be asking, sir, can we do this? This is most common mistake, let me tell you. Are you getting my point? Okay, if you check it out on the GATEOverflow website, all my answers on the indexing questions, okay, DBMS questions, if you check my answers, in the comments, 2-3 students will ask this doubt. That, sir, can we do this? Total file size divided by block size. Can we do this? This is wrong. This will not work in the unspanned organization because your organization is unspanned. In one, and also fixed length record. Yes or no? Also, you have fixed length record. So in one block, you can only store 4 records, nothing more than that. One block can store only 4 records. Okay. One block 4 records, one block 4 records, 4, 4, 4. Every block has 4 records. So what you should do? File has 20,000 records, divide by 4 records. Answer will be 5,000 blocks. You need 5,000 blocks. That is correct method. But if you find the total file size and then you divide by the block size, that will be wrong. That is most common mistake in indexing. You can write it. This is the most common mistake in the indexing for the unspanned organization. And you will find it in the comments, as I told you. So when you will be solving the GATEOverflow questions, at that time, whenever you see my answer, just go to the comment, you will see this most common mistake. Okay, so remember, this is wrong. Why this is wrong? Wrong because it is because of unspanned organization, which is by default. Okay, so remember, this is wrong. So remember, this is wrong. Okay, so what your answer you will get? Ekta, can you tell me? By chance, if you do this, what answer you will get? See, by chance, if you do this, like 20,000 records are there, multiplied by 113 bytes, divided by block size 512 bytes. Okay, can anyone calculate this? What answer you will get here? Anyone? Just calculate. Very simple. 20,000 records are there. These many records are there. This is the record size. One record has this size, and this is the block size. What answer you are getting? Nikhil is saying, see, without calculating, Nikhil is saying that it will be less. Agree or not? Right? Of course, it will be less. You will get less number of blocks. You will get less number of blocks. Okay, so you can calculate 4415. 4415. Of course, it will be less. Yes or no? Which is wrong? Because, see, why it is less? Because this formula is for spanned. If you have spanned organization, then you will get less number of blocks. So you are getting less number of blocks. Very easy. Because the reason is very simple. This is wrong. The reason is very simple that because you are doing what span organization. Okay, let's see this question. Tell me the answer for this question quickly. A very simple question again. For a variable length record, your variable length record, different records can have different size. We have done this, right? I think we have done this. So variable length record, you have average record size is given to you. Average record size is given to you, that is capital R. That is the average record size. Number of records is given to you, that is small r. Block size B bytes. K bytes used for block header. Span organization you have span organization. Then the number of blocks that we need. So your answer will be, actually this question we have already done. So yeah, okay. So this question actually we have already done. So anyway, what your answer? So number of blocks, you can see the blocking factor first. The blocking factor will be what? On average, you can notice span organization you have a span organization. So this is important. Okay, so average size is R. So your blocking factor will be what? That will be B divided by R. Okay, this will be your blocking factor because you have a span organization. Sorry, you cannot use the header. You cannot use these header bytes. Okay, so it will be B minus K divided by R because you cannot use the header. The header you cannot use. In the block, there is a header also. There are K bytes for header. So only useful bytes are B minus K. So the answer will be B minus K divided by R. Now, what is the number of blocks needed? Now, here you can use both the methods. Here you can use both the methods. Either you can say number of blocks needed, that will be. So this is the blocking factor. Okay, it means in one block, these many records you can put. Okay, in one block, you can put these many records. So number of records is R. Small r is the number of records divided by blocking factor. Or you can do what Priya was doing. Or you can do what Priya was doing. Priya was doing this. You find the total size, file size, right? Here you can do that. Ekta, yes or no? Here you can do that. File size you find divided by B minus K you do. Here you can do this. So this is interesting that this is interesting to know that at some points you can do this, at some points you cannot do this, right? Correct. So now you can do this because this is span organization. These are basically same. Okay, interesting, right? In one place you can do this, in one place you cannot do this. Why you cannot do here? Why you can do here? All these things, if you understand, then this will become a very easy chapter. This is a very easy chapter actually. If you let me tell you, this indexing, this file organization indexing, this is actually very easy chapter. But students don't want to understand this intuitively. Students want to apply the formula. Okay, this formula is there. Okay, let me apply this. Students don't want to do the visualization. Do the visualization. These topics are very easy. These questions are very easy. They look very, I can say heavy, right? These questions, if you notice, they look very heavy, right? Big questions. All the indexing questions are very big questions. If you see all the gate questions of the indexing, you will see all the file organization, this paragraph will be given. So when you read the question, it will be long. But when you solve the question by visualizing the concept, by visualization, if you solve the concept, by understanding the concept, if you solve the question, then the question is very easy. They look heavy, but they are not. Okay, let's see this last question. This is the last question for today's practice. If you can do this, every concept will be covered. Okay, let's see this. What the question is saying? Another very nice question. Okay, let's see this. So this is another Navathe question, and you will find this question very nice. So let's see this. What the question is saying, that suppose that only 80% of students, actually there are these many students. See, there are 20,000 students are there. Okay. Now you have variable length records of variable length. Now the question has variable length records. Okay. Records of variable length. So you have 20,000 students. These many records you have, 20,000 records you have. but they have variable length. These records have variable length. Different records have different size. Okay. Now what this question is saying, this is saying that 80% students have phone number. Is this clear? 80% students have the value for phone number. Remaining students, what is their phone number value? Anyone? Anyone? Tell me. 80% students have phone number. So the remaining students, they have null value for the phone number. Very good. So 80% students have the phone number. 85% have this code. 50% have this, and 90% have this. Okay, degree program. Suppose that variable length record is there. Okay, so very good. This question is given. So what the question is saying, that there is a student table. There is a student table. In the student table, what this question is saying? This question is saying that 80% students, they have phone number. Okay, 80% have phone number. What this is saying? 85% have what? 85% have phone number. 80% have phone number, and 85% have major department code. They have major department code. Major department code they have. Okay, and what else? 15%, only 15% have minor department code. What else? 90% have degree. 90% are doing degree. So the remaining, what they are doing? The remaining null, again, maybe freelancer, maybe diploma, whatever. So you can notice, okay, they have the degree program. The remaining are null. Okay, next. So suppose that this, every record has what? Has, okay, read this line and tell me what this line means. So read this line. What this line is saying? Every record, okay, so these many students records have this. Every record has one byte field type for each field in the record. For each field in the record. In the record, whatever field you are storing, for that you have 1 byte for field type, plus 1 byte for deletion marker, plus 1 byte for end of the record marker. Okay. So first of all, you find the average record length. With this information, you have to find the average record length. Looks like a complicated question. Agree? Looks like a complicated question. But take your copy pen and can you do this? You will find a lot of confidence if you can do this. Average record size. On average, what is the record size? Because the records are variable length. Because the records have variable length. Okay, so what will be the average record size? This is what the question is asking. Average record length. You will find a lot of confidence if you can solve this question. Take your copy pen. I'm giving you 1 minute. Just try, so that actually without trying, if you are watching this video as a recorded lecture, if you are not watching this in the live class, all those students who will watch this as a recorded lecture, they should pause the video. They should solve the question. The data is given here. The data is given here. Total 9 fields are there. Okay. Total 9 fields you have. Number of fields is 9. 9 fields are there, and those fields are already given to you. Take 1 minute. Let's do this actually. Just let's do this. Because if I leave it right now, I will again have to come back to this question. Okay. If I leave this question as a homework, then tomorrow I will again have to come back to this question. So take your time. See, take 1 minute, 2 minutes. Okay, like, okay, I'm not saying anything. Just take your time. If you need some data, you can tell me. This is the data. This is the data. Just think. Okay, very relaxed. Just think. Okay, I'm also relaxing. You also relax. The question has every information that you need. Think about this question and solve this. Whether you do this question right or whether you do this question wrong, it will give you confidence. That is the beauty of good questions. Have you seen in the GATE exam, sometimes there are some questions which we attempt in a very wrong manner, like we get the wrong answer. But when we see the solution, that gives us a lot of confidence, that gives us a lot of clarity of the concepts. Sometimes it happens. When you attempt the question, you will do it wrong. But when you see the solution, you will be like, wow, what a question, what an impressive question. Okay, you will forget, you will automatically forget whether you did it wrong or whether you did it right. But you will get a lot of confidence when you see the solution. So this question is one of those type. Do you need this data? If you need this data, you can take it. Take your copy pen and do it. Let's take 2 minutes, 3 minutes. All the students who are watching this as a recorded lecture, if you want to directly see the answer, you can do that. You can skip 2-3 minutes and you can see the direct answer. But I would suggest, this is my suggestion, that you try. Whether you get the right answer, whether you got the wrong answer, does not matter. It does not matter whether you get right answer or wrong answer. Just try. This is the percentage slide. What is the average record length? One record has, what is the length on average? Okay, today we will not be able to start the indexing because of these questions. But I hope you are like this session. I hope you are finding this session very nice. That okay, magnetic disk questions, file organization questions, all the concepts are covered, right? Spanned organization, unspanned organization, variable length record, fixed length record, block header, record header. You tell me one concept which is not covered in these questions. Every concept is covered. Seek time, rotational latency, I can say whether you have random access or whether you have consecutive access, like everything, track capacity, uh, number of cylinders, cylinder capacity, disk capacity, useful capacity, total capacity, how much useful, how much total. So if you think these 4 questions that we have taken, they cover everything. They cover every single thing. And also that Ullman question, how to store the record. Like you store every field at a multiple of 4. You store every field at a multiple of 8. Or you can store any field anywhere. So those were the 3 variations. So these questions, I think these questions are covering everything in the file organization, in the magnetic disk. These 2 things, every concept. Okay. So anyone want to give me the answer for this question? Anyone? Write the data in your notebook. Nikhil is saying 107 byte. Nikhil, that is not correct. 107 is not correct. Mm. Can you tell me your thought process, Nikhil? Can you tell me your thought process? ले सकते हैं. No, no, no. Priya. Different records have different percentage. See, different fields. Priya, different fields have different percentage. So we have to do that. Column by column. Yes, very good. We have to do column by column. Column by column we have to do. Okay, let me do this. Let me do this. No, actually, let me do this question. Not much time consuming. This is actually, this question is not time consuming. Okay, let's see this. So let me solve this question. Before I solve this question, let me take one analogy. Okay, because this type of situations you will feel everywhere. Okay, let's take this question. Let's assume there is a city. Okay, and actually this analogy you already understand, because you will give me the correct answer. Okay, so this is a city. Remember, you are going to give me the correct answer. Let's assume in this city there are, let's assume 5 houses are there. Okay, 5 houses are there. There is house 1, house 2, house 3, house 4, and house 5. Okay, or I can say maybe in this city there are, there are actually many houses. There are many houses, 100 houses, but every house, there are 5 items. Look at the 5 items. Like there is a TV, there is a laptop, there is a maybe car, there is a maybe I can say pen, and something else, maybe washing machine. Okay, washing machine. So these are the 5 items. Now let me assume there are 100 houses, and I am saying that everyone has this. Okay, everyone has this. So this everyone has. Okay, right, correct. This everyone has. Let's assume this everyone has, and let's assume this this is costing 5 rupees. 5 rupees it will cost. Okay, let me assume that 80% people have this. 80% people have TV. Okay, 80% people they have TV, and let's assume this is costing 200 rupees. Let's assume 40% people have laptop. 40% people they have laptop. Okay, and let's assume this laptop is costing maybe let me take 600 rupees. This car, let's assume 20% people have this car. Okay, so car 20% people have, and this car is, let's assume this is costing maybe 1200 rupees. Okay, now this washing machine, let's assume maybe you can take again 90% people you have this washing machine, and let's assume this washing machine has is costing maybe 200 rupees. Okay, so this is the data that is given to you. Now you tell me what is the average cost of one house. So did you understand this question? Okay, there are 100 houses. These are the items. 80% people have this. 90% people have washing machine. Okay, so this is, now can you notice? Can you notice this question is simple aptitude question? Do you agree? This is simple aptitude question. Nothing actually. You don't have to use any brain. This is aptitude question. Nothing more than that. Okay, so everyone has a pen. So find the average cost per house. Find average cost per house. Like average cost you find. Find average cost of one house. Of one house. Okay, you have to find the average cost of one house. For one house, what is the average cost? Now, remember this question is nothing but a aptitude question, a general aptitude question. Nothing more than that. So what the answer will be? You can notice everyone has a pen. So the cost will be what? Average cost. Average cost we find on 100 or what we find on 1? Average cost we find on 1 or on 100? We find the average cost on 1, right? So this you already know. These things you already know, but I am again telling you. So this average we find on this average. Okay, this average we find on 1. Find on 1 person, 1 element, 1 entity. Okay, so we find this on 1 entity, correct? On 1. Now you can notice very simple that now 80% people they have TV. 80% people have TV. So one person has how many TV? One person has how many TV? One person has how many TV? How many TV? 80% people have TV. Okay. Okay, 80% people they have TV. 80% people have TV, remember. So one person has how many TV? One person has 0.8 TV. Yes or no? Correct? Is this clear to everyone? Let me know. See, very simple. Is this clear? Let me know. So 80% people have 80% people have TV. 80% people, they have TV. Then in this situation, one person has how many TV? One person has 0.8 TV. Is this clear? Let me know. So very simple. So the same thing you have to do here. Average cost will be 5 rupees for pen, everyone. 5 rupees for pen. Average cost means per person. Average cost simply means per person. One person is giving how much rupees? Okay, so every person is giving 5 rupees. Okay, for TV, one person, how many? For TV, one person is spending how much? Let me know. For TV, one person is spending how much? One person is spending only this much. One person is spending only this much. Correct? One person is spending. Actually, this 100 houses does not matter. Okay, this 100 houses does not matter. You can have any number of houses. You can have, for example, maybe you can have 625 houses, doesn't matter. It doesn't matter because we are talking the percentage. Yes or no, agree or not? We are talking in terms of percentage. So this does not matter how many houses you have. This does not matter because we are talking about the terms of percentage. So 80% people have TV. It simply means one person has how many TV? These many TV. So you can see here that 200 people will have this much TV. Okay, sorry, 200 rupees for one TV. So one person will spend this much. 200 multiplied by 0.8 TV. Because this is the number of TV per person. Agree or not? This is the number of TV per person. Yes or no? This is the number of TV per person and this is one TV cost. This is one TV cost. So plus what you will do? The same thing you will do. 600 is one laptop cost, but one person has these many laptop. Okay, similarly, I can say 1200 is one car cost, but 0.20 people have a car. 0.20. These many car per person. And finally, I can say 200 for washing machine multiplied by 0.9. This is your answer. Is this clear? Nikhil, this is aptitude. This is aptitude. A percentage, we are already saying 80% people. It does not matter what you put here. It does not matter what you put here. We are already saying 80% people. Nikhil, I am already saying 80% people have, and one person cost I am finding. I am finding average cost. One person cost I am finding. And I am saying 80% people have. So this value does not matter. This is just to confuse. This value does not matter. This is just to confuse because this percentage is given. Is this clear? The data is given in the percentage. So when the data is given in the percentage, this data does not matter. This is just to confuse so that in the aptitude, this question can come. Is this clear? Tell me average cost. Is this clear? On average, per person cost is this. This is the on average per person cost. Now let's come to same question. So now can you see this question is just an aptitude question? This question is only aptitude question. One more thing. Okay, one more thing. Let me know. One more variation. One more aptitude variation. Let me do. One more aptitude variation. Just one more variation. Because I want to tell you that this question is only aptitude question. Okay. So let's see one more question. Let's assume again you have now you have, let's assume 800 people, 800 houses. This data doesn't matter. Okay, and I'm saying that let's assume you have TV and only two things I have. You have TV, you have car. Let's assume that TV, 80% people have this TV. 80% people have this TV. But if they have TV, then they will also purchase the remote. Yes or no? If they purchase the TV, then remote will also come. 80% people have TV and this TV will cost 600 rupees. Okay, and this car 20% people have. This car 20% people have. Let's assume this is costing maybe, okay, you can assume that this is costing 1200 rupees. Now you tell me, and this data I'm giving you, what data I'm giving you? So if you have TV, what comes with it? If you have TV, then 20 rupees remote comes with it. Remote comes with it. Now you tell me average cost per person. Tell me. Now you tell me this. Okay, so if you purchase the TV, then 20 rupees 20 rupees remote also comes with it. So now you tell me the answer. So average cost, what that will be per person? One person, for one person, how much cost? So that will be very simple. See, that is very simple, that 1200, but one person has 0.20 car. One person has this much amount of car, one person. And this is the cost of car. This is the number of car per person. This is the number of car per person. One person has this much amount of car. Okay. And what else? Plus what you will do? Plus you will do, see, only 80%. One person has this much amount of TV, but actually the TV basically now this is the cost of TV. Do you agree that cost of the TV becomes this? Okay, the cost of the TV that becomes this. Very simple. So this is your answer. Now the same thing we have to do here. I just want to tell you that this question is nothing but an aptitude question. Now let's see the average record size. Okay, let's find out. Let's find out what is the average record size. So that will be this. First of all, everyone has name. So let's see average one record size. One record size. Everyone has name, right? Correct? Yes or no? Everyone has name. Every student has name. So this 30 byte student, this 30 byte will be given by every name. Name has 30 byte. Okay, so this 30 byte for name. This everyone has. This is for name. It will everyone have. Everyone will have this. This SSN 9 bytes. This also everyone will have. 9 bytes for SSN. This also everyone will have. What else? Okay, what else everyone will have? This address everyone has 40 bytes. Okay, these 40 bytes address, everyone has this. Every record has this. I'm asking average record size. Okay, every record has this. What else? Phone number 10 bytes, but this 10 bytes. Okay, but something interesting. Something interesting. See, 1 byte you are giving to, see this statement you see. Focus on this statement, that in the record, each field in the record, for each field in the record, you store 1 byte field type. Okay, in the record, whatever field you store, will every record have phone number field? Tell me, will every record have phone number field? Will every record have phone number field? It will not have. Okay, because the question is already saying this is a variable length record. Remember, these are variable length record. So do you remember I told you that we don't store the null values? Are yes or no? In the variable length records, whenever you have variable length records, the null values we basically don't store. So some records will not have the phone number field. This phone number field will not be there. Only 80% records, only 80% students record have this field. The question is already saying every information is given in the question. You don't need any extra information. Outside of this question, you don't need any extra knowledge. This question is already giving you every knowledge that you need, that only 80% student records have phone number value. And the question is saying that each field in the record has 1 extra byte. Okay. each field in the record has one extra byte. Are you getting my point? So for example, this will have one extra byte. This will have one extra byte. This will have one extra byte. Okay, each field will have one extra byte. What about phone number? What about phone number? Either you don't have it or you have it. Of course, 0.88, these many phone number you have per record, right? This is the number of phone value per record. Yes or no? So per record, you have these many phone number values. In one record, you have these many phone number values. So this you should multiply with what? 10 bytes plus 1 byte. Array, see, if you don't have, it's like remote. It's like this is your house, this is your TV, this is your remote. Because see, okay, should I keep it separate or should I keep it should I keep it separate? Should I keep it separate? 1 byte. Should I keep it separate? Tell me, Nikhil, Priya, Mavith, tell me, should I keep it separate? No. If you have phone number, then you put it. If you have phone number, then this 1 byte will be consumed. This 1 byte will be consumed if you have phone number. So in these situations, you have phone number. So this 1 byte will be consumed in these situations. Plus, what is the next? The next is what? So the next is after phone number, birthday date. Everyone has this birthday date, 8 bytes. So 8 bytes for birthday date plus 1 byte. This is for birthday. And of course, plus 1 byte. This extra. Plus, what is the next? The next is saying 1 byte for sex. So this 1 byte. This 1 byte for sex. And what you will do? Plus 1 extra 1 byte. Because this is also in every record. Every record has this. Next, major department code, 4 bytes. What about this? Tell me. Major department code. So major department code, that will be what? So that will be 0.85. Because 85% people, remember 85% people have major department code. 85% people. So that will be 0.85 multiplied by how many bytes for major department? That is 4 bytes. So that will become 4 plus 1, right? 4 plus 1. Plus next, that will be 0.15 multiplied with 4 plus 1. This will be for minor department. For minor department also, you can notice 15% have minor department. So that will become 0.15. This is for major department. And this is for minor department. Plus, what else? Class code everyone has. 4 bytes plus 1 byte. Okay, 4 bytes plus 1 byte. This is for class code. Plus one last thing, that is degree program, 3 bytes. Okay, so the degree program, 90% people, 90% record have degree program. So this will be like, I can say 0.90 multiplied by 3 bytes, 3 plus 1 byte. So this is your answer. Okay, how was the question? Actually, this question is just an aptitude question. See, this question is not really complicated. See, okay, how hard is this question? Tell me. How hard is this question? Is this more than aptitude? In this question, all the things that we are applying, is this more than aptitude? Like very easy aptitude question is this, actually, if you notice. Per record, we have to find. Okay? Per record, we have to come. That is the reason some analogy I gave you. After this analogy of house, TV, or this analogy, is this becoming easy? Please tell me. After this TV, remote, all those things, washing machine, after that analogy, 2 questions we have done from the aptitude. After that, this question has become easy or not? Okay, well, like whatever works for you, you can do that. Mavith is confused with the analogy that you can forget about the analogy. That is the benefit of analogy. If it helps you, then very good. If it does not help you, you can forget about it. Okay. So very simple. So your answer will be finally your answer. Can anyone calculate this answer? And remember, some more things are there. Some more things are there. What are those? 1 byte for deletion marker and 1 byte for end of the record marker. Okay, so there are some extra things. So record size, there are some extra things. What are those? Some extra things are there. These are some extra things. 1 byte for deletion and 1 byte for, these are extra head record header. So these 2 bytes are extra. These are given for block header. These are block header. 5 bytes, these are the block header. These are not the record header. Every block has this. Every block has these 5 bytes. This is the block header. A block header has every, this will be for block. For every block, this data you have, not for every record. In the record size, you will not use this. So your answer will be what? Anyone? Final answer? Anyone here? Record size, final answer. Anyone who calculated? Anyone who calculated this answer? What is that? Let's just calculate. You can find it. Okay. So whatever is this, you can find it. And this, yeah, of course, this is record header. This will come in the size of record. So that is the reason plus 1 byte plus 1 byte. Okay, so Priya is saying 114 plus 0.4. You can check it out. Okay, but this on your screen, whatever you have, this is your answer. Okay, so that's it. So finally, next, calculate the number of blocks needed for the file. What is the number of blocks needed for the file? This you can calculate. Previous slide. Previous slide, calculate. I think it will be 116.4. Priya, you can check it out. I think it will be something here or maybe more. You can check it out. Okay, I am leaving it up to you. You can see this, what it becomes. Okay, I am leaving it up to you. So you can calculate from this slide. I don't really know how much it will become, but you can check it out. Whatever is this. Okay, anyway, what is the number of blocks needed? What is the number of blocks needed? Remember your span organization you have. Your span organization. Okay, so and header size is also given to you. So this becomes very easy. How many block size are needed? So this will become very easy that you have 20,000 records you have, correct? This divided by, or maybe you can do this 20,000 records multiplied with this record size. Let me call this record size theta. Let me call it theta. So this theta you put here and divided by block size, that is 512 minus 5 bytes. This will be your answer. This is going to be your answer. Okay. So block size minus 5. So this will be your answer. This will be the number of blocks needed. That's it. This is your practice for today. Anyone has any doubt, let me know. In this analogy, if you have doubt, let me know. So 20 repos, extra rupees you have to give. So that is the reason 600 plus 20. This will be 620, Nikhil. That you can calculate. Take your calculator and calculate what this value will be. This value will be, if you calculate this value, you can just check it out. Maybe like whatever is this value, you can calculate. I did not calculate the final answer, Nikhil. You can calculate this. I did not calculate the final value. That you can do. Okay, so these are your questions. So I hope you understood everything. I hope you liked these questions. Any doubt? Let me know. Please tell me. Did you really understand these questions or not? In these questions, we have taken everything. See, we have taken spanned organization, unspanned organization. Many questions of unspanned, many questions of spanned. Many questions of fixed length, many questions of variable length record. Okay, so number of blocks in every situation. Okay, we have done every situation. All the 4 situations we have done. And this last question, this is really interesting. In the last question, basically what you are doing in the last question, it's just aptitude. Okay, it is simple aptitude. Okay, like if you solve these questions, let me tell you, after this session is over, take 10 minutes. Okay, listen to some song, relax, and then you think about this last question. You will think that this is actually easy question. Are you getting my point? You will find this is actually easy. Okay, this question is actually easy. If you think about it, 10 minutes, take a 10 minutes break, then you think about it. Okay, so this question is actually easy. And one thing, once you solve this question, once you have done this question, now similar questions if I give you, you can solve them very quickly, right? Sometimes the first question takes time, like that is your seek time. Yes or no? It happens in the learning also. Basically, when like first time it is taking time, you can call it seek time. Whenever a new variety of question, a new variation of question, whenever it comes in front of you, for the first time, it will take time. I agree. 10 minutes, 20 minutes, 30 minutes. Okay, first time, once it will take time. That is your seek time. Okay, once you do this, then after that, now if I give you similar question, some little bit variation, similar question, if I give you, or maybe similar question comes in the GATE exam, then you will be able to do this very quickly. Yes or no? Very quickly you will be able to do this. Tell me, this question that we have done, the last question that we have done, if I give you similar question now, how much time it will take? Very quickly you can do, because you understood the concepts. You understood what is happening. So I agree that first time, whenever you see a new variation, it will take time. In the GATE exam, almost 10 questions are new variation questions, or maybe 10 or 20. Let me tell you that from your notes, as it is, almost 40 questions will come. 40 or 45 questions. If you combine all the coaching institutes, okay, all the coaching institutes, NPTEL, everything, if you combine, then almost I can say 45 questions will come from these direct. Okay, but there will be some 20 questions of new variations. And if some coaching institute is saying that 62 questions are coming from our notes, okay, you will find GATE exam is also thinking, GATE professor is also thinking that I put so much efforts to create new variations, and okay, I'm putting so much effort, okay, to define a new terminology. Okay, I'm defining new concept, new terminology, I'm defining new question, I am putting so much effort to give these stupid people a new I can say variation, and they are saying that it is coming from my notes. Yes or no? So remember, from your notes, almost 45 questions will come from your notes. But the 20 questions that will come, the remaining 20 questions, these questions you can solve with your analytical skills. The remaining 2 questions, of course, the remaining 20 questions also you can solve, but with your problem solving skills, with your analytical skills. Okay. So that is the reason every day you improve your analytical skills, you improve your problem solving skills, and that is what we have done. So I'm very excited that goclass students, when they give the GATE exam, I'm very excited that those straightforward questions, of course, you can do very easily. You can do. Everyone will be able to do. You will also do. Everyone will also do. But these analytical questions, these 20 or 25 analytical questions, I think that is the area where goclass students, they will get the, I can say, benefit. They will get the advantage. That is the area. Okay. And that is the area that will make you topper, remember. Because if there is a question which everyone can solve, if there is a simple scheduling question, everyone can solve that question, then that question is not going to make you topper. Of course, if you wrong that question, that will definitely make you non-topper. Okay. But that question cannot make you topper. If you correct that question, it will not make you topper. If you wrong that simple question, then definitely it will decrease your rank, because everyone will be able to solve that question. But these questions, these 20, 25 questions, these analytical questions, problem solving skills questions, These questions, every question will improve your rank. Each question, there are 25 questions analytical. Each question will improve your rank. If you can solve 5 or 10 questions, your rank will improve a lot, because many people will not be able to do these. Those students who are by hearting the concepts, who are by hearting the notes, okay, in the notes this is given, I understand everything that is given in the notes, I understand. These students will not be able to solve these analytical questions. Okay, so anyway, these analytical questions will decide your rank, remember. Okay, so if you think about it, today whatever questions we have done, okay, in all the questions, I can say, if you think about these questions with a calm mind, you will see that these questions are really easy. The last question is also very easy. Now, if of course the first time maybe you are not finding this easy, but the second time this becomes easy. What you do, the same question you solve again. Okay, this same question, this last same question you solve again, you will definitely find that, okay, this question is really easy. Okay, okay, thank you everyone. And tomorrow we will start the indexing. Actually tomorrow we will have class at 8 p.m, but after that every day we will have class at 6 p.m. So I will give you schedule today. Okay, right now I will give you a schedule, or maybe I will schedule the live classes. The next 7 or 8 live classes I will schedule right now. Okay, for the next 8 days, all the classes I will schedule. Okay, so tomorrow we will have class at 8 p.m. Okay, because I have some work in the afternoon. 8 p.m. we will have the class, DBMS class, and after that every day we will have 6 p.m. class. Okay, every day 6 p.m. After that every day continuously, even after syllabus is over. When syllabus will be over, then also we will continue practice revision, gate questions, gate summary lectures, all those things we will continue. Okay, thank you everyone.